It looks like you have to scan the whole garden for every flower, but the real trick is to treat the edges as empty spots and then count 3 0 windows in one pass. You are given a row of plots represented by an array of zeros and ones, where a 1 means a flower is already planted and a 0 means the plot is empty. The rule is that no two flowers can be adjacent. The question asks whether you can plant a given number of new flowers without breaking that rule. For example, if the garden looks like 1 0 0 0 1 and you need to place one new flower, you can put it in the middle 0 because both its neighbors are empty, so the answer is true. A naive approach walks through each plot, and whenever it sees an empty slot it checks the left and right neighbors. If both neighbors are empty, it plants a flower there and decrements the needed count. The loop continues until either all flowers are placed or the end of the array is reached. This method visits each element once, so the time complexity is linear in the length of the array, OM. But it also modifies the original array in place using only constant extra space, big O of 1, constant time. The drawback is that it performs the neighbor checks for every 0, which can be unnecessary work when large blocks of zeros exist. The key insight is to pad the garden with an extra empty plot on both sides, turning edge cases into the same pattern as the interior. First we create a new array that starts with a 0, then copies the original garden, and ends with another 0. Next we iterate from the second element to the second last element. For each position we look at 3 consecutive values, the current plot and its immediate neighbors. If all 3 are zeros, we plant a flower by setting the middle to 1 and increase a counter. After the loop finishes, we simply compare the counter with the required number of flowers. This gives us a clean, single-pass solution that treats edges uniformly. You'll recognize this pattern whenever you have a linear constraint that depends on neighbors. Just pad the structure and look for 3 0 windows. The algorithm runs in OM time, scanning the array once, and uses OM extra space for the padded copy. If you like this greedy edge trick, try the next problem that uses the same sliding window pattern, and don't forget to like, subscribe, and hit the bell for more algorithm deep dives.